Hey, what's going on, students? I want to show you how to do stuff from section 4-4. Here's the 4-4 overview. How to graph a function by hand. So I'm going to show you several of these and how to do them by hand. And then I'm also going to show you a fast way that you can graph these, or at least make the table, which the table will make the graph. I'll show you how to make the table very quickly in your calculator so we can kind of speed things up, because overall, remember, we want to do things slow and smooth, but we also want to be very, very efficient at them. So let's go ahead and try to be slow and smooth here. So most popular tables, the most popular table you should use when making coordinate points to a function is this table right here. Make an XY table, start at -2, then go -1, then go 0, then go 1, then go 2. Why do we pick these? Because they're very, very close to the home base of the origin. And most of the lines that you're going to graph are relatively close to the origin. If the equation is way off and it makes a bigger graph, we'll deal with that when we get there. But for right now, this right here is the home base table. Start here. Now all we're going to do is we're going to put these 5 x values in and then get 5 y values out. Now down the road there will be a trick that you may see with these two numbers, the -7 and the 3, and then kind of some numbers that happen to show up in our table. But for now, let's just work on physically plugging them into the calculator and getting answers. Now, there's some teachers that would make you even write it out, so I'm going to write this first one out here. Some math teachers would make you write out 3 times, no longer x anymore, but this -2, and then go -7, then do it over, and then plug in the -1, and then plug in a 0. Then some math teachers would make you do that over and over and over again. I don't really care because that's kind of inefficient, to be honest. It's kind of a waste of your time. So let's go ahead and start, and then just kind of start plugging away here. So 3 times a -2 minus 7 is a -13. Okay, I'm going to write that down. Okay. Go to the same equation, type in a -1. Make sure you do it the exact same way. Don't change things. We got -10. So you might be able to see a number here. -13, -10. No, that's just +3. Weird, right? Let's plug in a 0. Oops. 3 times 0 basically makes the 3 go away. -7. -7. Weird. So just in our first 3 values, the -7 shows up, and then these numbers seem to be increasing by 3. Interesting how that works out. Plug in a 1. -4. Plug in a 2. Now you probably don't even need to plug in the next one. You probably know what it is just by number sense, spatial sense, spatial awareness, all those fun things. -1, weird. So it seems that all of our numbers increased by 3. Weird. And then when I plugged in a 0, I got a -7. Interesting. So these are all coordinate points, students. This is the coordinate point -2 and -13. This is -1 and -10. This is 0 and -7. So over here, as you can see, I've made a blank graph, and I think I've made enough room to graph all these coordinate points. I'm going to go ahead and try my best here. So -2 and -13. There's -2. We've got to go down 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All the way down there, almost off the video. Okay, the next one is -1 and 10. -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oof. 0, -7. 0, don't move. 1, 2, 3, 4, 5, 6, 7. 1, +1 and -4. 1, 2, 3, 4. Here we go. We're a little closer to home base here. 2, and then -1. Okay, we got them. There we go. There's our coordinate points. Now we could grab a ruler device type thing, a straight edge, and we play connect the dots and graph our line here and make it nice and pretty. Line it up nice and nice like, and then boom. There we go. Oops, I about knocked the camera over. Okay, got them. There it is, friends. So again, there's another thing that I want to highlight here. I'm not going to go over this every single time, but especially when it comes to linear equations. Linear. Why is it linear? Well, it makes a straight line. When it comes to linears, that number 3 and that -7 kind of seem to show up again over here. So if you notice, there's these things called intercepts. So what is an intercept? An intercept is when you actually hit an x or a y axis. So remember, this is the x-axis and this is the y-axis. This is the origin. This is 0, 0, blah, blah, blah. You guys have all heard that a billion times. So right here, this is called an intercept. Okay, why do you call it intercept? It's where it crisscrosses with the y-axis. This one in particular is called the y-intercept. So where did it hit? It hit where y equals -7. Weird. -7, -7. Interesting. And then how does this line move? Well, like a stair step. How do the stair steps? Because you can make this line kind of bend and go any way you want, but it seems to me that our line goes 1 to the right, and then it goes up 3. 1 to the right, up 3. 1 to the right, up 3. Weird. 3, -7. 3, -7. There was a -7 in there, and they increased by 3. Weird how those same two numbers kind of tell the same story over and over again. Anyway, not a coincidence. Eventually, someday, you'll get to the point where you see this, and you're going to go, boom, right to the line. Oh, I'm going to start at -7. I'm going to go 1 to the right. I'm going to change the height by 3. You're going to hear that a lot in the future when we do more things in class. So anyway, that's how you graph by hand. We'll get into those smarter moves later. But for right now, all you got to worry about is plugging in the x values and then having the y values shoot out of your equation that you plug in carefully. And then you can plot your corner points and you can graph your line. You only need a couple, but it's nice to have a handful so you get the big picture. All right, next example coming in hot.